Hello, dear students. Uh, Yesterday we have studied about the methanol. Methanol is known as the wood spirit. Methanol was prepared. Methanol was prepared by the destructive distillation of the wood, but remember it was prepared in this method. Nowadays, most of the methanol is prepared by the catalytic hydrogenation of carbon monoxide at high pressure and temperature, and in the presence of zinc oxide and uh, chromium oxide. You can see it easily that we use this catalyst for the preparation of methanol. So when carbon monoxide and hydrogen gas, they react with each other at the pressure of 200 to 300 atmospheric pressure and 573 to 673 Kelvin temperature, we get methanol produced. Dear student, this methanol is a colorless liquid. It is highly poisonous in nature. Ingestion of small quantity of methanol can cause blindness, but if we take the large quantity of methanol, it can even cause death. Methanol is used as a solvent in paints, varnishes, and chiefly for making the formaldehyde. So from methanol, formaldehyde is also prepared and it is used as a solvent into the paints and varnishes. Now, my dear students, we are going to study an important alcohol, that is what it is known as the ethanol. In ethanol is obtained commercially by the process. This process is known as the fermentation process. Fermentation of molasses generally takes place. This molasses is full of sugars. So this molasses contains sugar. So the sugar present in the molasses turns into glucose and fructose. So this sugar present into the molasses turns into glucose and fructose in the presence of the enzyme which is known as the invertase. So we can see here that molasses, that is the sugar C12H22O11, in the presence of water and the enzyme invertase, turns into glucose and fructose. This particular reaction is known as the inversion of sugar. So, and that is why the enzyme used in this particular reaction is known as the invertase. Now, this glucose and fructose undergoes the fermentation. Glucose and fructose undergo fermentation in the presence of another enzyme which is known as the zymase. This zymase is found into yeast. So, here we have yeast. This yeast produce two enzymes. One is known as the invertase, another is known as the zymase. So in the presence of zymase, our glucose or fructose, which are produced into the previous step, they undergoes the process and they produce the alcohol, my dear students. At the same time, the carbon dioxide gas is even produced. The same fermentation process is used in the wine making. The same fermentation process is used in the wine making. So in the process of wine making, we use grapes. These grapes are the source of sugar. So we get sugar from the grapes. Grapes are the source of sugar, and yeast. We have just seen that yeast provides us the enzymes for the reaction. The two enzymes which are needed, one is invertase, another is known as the zymase. Both these enzymes are produced from the yeast into the anaerobic conditions. we'll see that during the wine making we maintain the anaerobic conditions. As grapes ripen, the quantity of sugar increases and yeast grows on the outer skin. Please remember that yeast grows on the outer skin of the grapes. When grapes are crushed, when they are completely ripened, they themselves are being crushed, sugar and yeast come in the contact with each other. Yeast produces enzymes present in the yeast, and this is how the fermentation process takes place. Fermentation process takes place into the two step. In the first step for fermentation is the, if we really look at the fermentation, my dear students, if we really look at the fermentation process, fermentation takes place first is the inversion of sugar in the enzyme that is invertase, and the second step is conversion of sugar to alcohol, and carbon dioxide is also produced. This alcohol maximum it goes up to 14%. Let us so, and why do we do fermentation in anaerobic condition? We do fermentation in anaerobic condition for two reasons, my dear students. Let us study why fermentation is done into the anaerobic condition. Fermentation is done in the anaerobic condition, my dear students, because number one, yeast gives us the zymase and invertase. Only in the anaerobic condition. And second, ethanol, if air is present, it oxidizes to the ethanoic acid. And thus, if this ethanoic acid actually destroy the taste of wine. So these are the two major reasons why we need to, or why wine making is done in the anaerobic conditions. Now let's move forward and understand the next part. Here in the process of fermentation, carbon dioxide is released during the fermentation. The action of zymase inhibits zymase inhibit once the percentage of alcohol exceeds 14%. If air gets into the fermentation mixture, the oxidizes ethanol to ethanoic acid, which in turn destroys the taste of the alcoholic drinks. Now, my dear students, we are going to study about the various properties of ethanol. Ethanol is a colorless liquid. It has got the boiling point of 351 Kelvin. Now we will study the uses. So it is used as a solvent in the paint industry and in the preparation of a number of carbon compound. Commercially, alcohol is prepared. Commercially, alcohol is prepared or made unfit for drinking by mixing some copper sulfate and the pyridine. Copper sulfate is added to add the color, blue color, and pyridine is added for smell. So pyridine has got a special smell, and this process of adding copper sulfate and pyridine to alcohol for making it unfit for drinking, this particular process is known as the denaturation of alcohol, and such alcohol that contains methanol. See, alcohol, that is what we have: ethanol, then we have so if we have ethanol, then if we have methanol, then if we have copper sulfate, then if we have pyridine, the mixture of all these four is collectively known as denatured alcohol. So we call this mixture as a denatured alcohol. Now, my dear students, we want to understand the preparation of ether. So now we are going to study the special part of this chapter, which is known as the ethers. Let us first study the preparation of ethers. Ethers are prepared by the dehydration of alcohols. So when ethers are, or when alcohols are heated, please pay attention to this. When alcohols are heated, especially with sulfuric acid, when alcohols are heated with the sulfuric acid, at particular temperature, we either get ethene or we get ether. If the temperature is kept 413 Kelvin, we are going to get ether. If the temperature is kept higher, then we are going to get ethene. So at different temperature, we get different products. Let us read the text, what is written over here, that alcohols undergo dehydration in the presence of protic acids such as H2SO4 and H3PO4. The formation of reaction of product alkene or ether depends on the reaction conditions. For example, ethanol is dehydrated to ethene in the presence of sulfuric acid at 443 Kelvin. So that is what we have seen, my dear students. Let's move forward and understand the mechanism for this reaction. You can see here that when ethanol reacts with sulfuric acid at the temperature of 413 Kelvin, we get ethoxyethane. So this particular reaction takes place into the various steps. The formation of ether is a nucleophilic bimolecular reaction. So please remember that it follows the SN2 mechanism, involving the attack of alcohol molecule on a protonated alcohol. So we'll see them step by step. First, what happens from H2SO4, we get H plus, and this H plus enters into the first step. In the first step, ethanol reacts with H plus. So the lone pair of electron present on oxygen of ethanol attacks on H plus, and we get protonated alcohol. This protonated alcohol has got only one lone pair on oxygen and positive charge on oxygen. This positive charge on oxygen is not so stable. So in the next step, this protonated alcohol reacts with the another molecule of alcohol. The another molecule of alcohol has got oxygen, which has got the two lone pairs. So this lone pair of electron attacks on the carbon of protonated alcohol, and ultimately the additive product is obtained. But you can see here that the bond between carbon and oxygen into the protonated alcohol get broken. The electron of this bond comes on oxygen, and finally this this product of which is known as the protonated ether as well as water is produced. As the electron from this bond comes on oxygen, the water molecule has got two lone pair on its oxygen. Now, my dear students, the protonated alcohol enters into the third step. So in the third step, protonated alcohol, which has got positive charge on oxygen and only one lone pair on oxygen. This oxygen of protonated ether gets one more lone pair by breaking of bond between oxygen and hydrogen, and finally we get ether. You can see in ether that the oxygen has got two lone pairs and hydrogen is removed as an H plus. You can see here this H plus is obtained. We know that this H plus is needed into the first step, my dear students. So H plus, whatever it is obtained during this process, is required into the first step. So here you can see that this H plus, which is produced in the last step or which is produced in the first step, this H plus, again it can be utilized for the first step of the preparation of ether, and this is how the ether is being prepared. Now my dear students, we can see that what kind of ethers are produced by the dehydration of the alcohol. So preparation of ethers by the dehydration of alcohol, it's suitable for the preparation of ethers which are having only the primary alkyl group. Second, the alkyl group should be unhindered. That means it is primary, it should not be secondary or tertiary. The third one is the temperature should be kept low. That means the temperature should be kept 413 Kelvin. But if the temperature gets 443 Kelvin, we do not get the exact product, and ether must be symmetric. That means ether must be ROR, not ROR dash. So this kind of ROR dash kind of ethers cannot be produced by this reaction, but we can produce only the symmetric ethers by the dehydration of the alcohol. This is how, my dear students, we understand the preparation of ethers by the dehydration of alcohol. I hope, my dear students, you are enjoying your studies. Happy learning.